In this video, I'm going to run through a number of examples on how to sketch graphs of trigonometric functions. Now, I do it by looking at the base graph and then applying transformations. There are lots of different ways that you can do this, so if you would rather do it a different way, that's fine. This is just one way that you can go about it. It's something that I find fairly logical and systematic, and it usually guarantees that you don't get it wrong. So what we're going to look at to start with is, what are we doing with our trig graphs? Basically, the principles of transformations that we apply to all functions, so your dilations and your translations, also apply to trig functions. Okay, so if we think of this in your sort of f of x kind of format, then you'll remember that this is your vertical dilation over here. So we've got vertical dilation, just the same as if you're doing it for a polynomial or quadratic, whatever. Okay, this is your horizontal dilation. It's affecting the x, or in this case t, horizontal dilation there, and then this one here is your horizontal translation, and we don't have a vertical translation in this particular function, but we will get to that. Horizontal translation. Okay, just a little note here that when we're talking about trig graphs and trig functions, the horizontal translation can also be known as a phase shift. So if you're talking about a phase shift, that means this unit here, how far are you shifting it, left or right, and that's because of the cyclic nature of your function. Another thing just to remember is the order of transformation. So remember, you can always start with your vertical dilation. That's a safe bet, so start with that. But you need to make sure that you get these two in the right order. Okay, if you've got the dilation outside the brackets, okay, that means that you are dilating first and then translating. It's sort of like reverse BIMDAS. So it can get a bit confusing. But if you remember that we're replacing, so if we started with sine of t, okay, we replace that with sine 2t, there's your horizontal dilation, and then we just replace this t, sine of t minus pi over 4. Okay, and so that's dilation, and then that's translation. Okay, so that's the way to sort of think about it, or you can just memorize it. Reverse BIMDAS, or if there's the dilation outside the brackets, it means dilation first. But it is important that you get those in the right order. Okay, so to sketch this, what I always start with is the base graph. Okay, so your base graph is y equals sine t. Okay, and the reason I like to do this is to get the shape, my starting point, so I know that it starts at 0, it goes like this. Okay, that's 2 pi there, I know that's 1, that's minus 1. Okay, so this is my base graph. Now I'm going to apply transformations to it. So I know that I've got a vertical dilation of 3, so it's going to stretch up that way, which is cool. Okay, so we can do this one at a time. So I'm going to stretch it up this way. So now we've got, that's 3, that's minus 3. Okay, and at the same time as I'm doing that, I'm going to apply my dilation here. So remember, when you're doing a horizontal dilation, it's the inverse. So you've got a dilation of a half, horizontal dilation of a half, which means it's going to squish inwards, which means if this was 2 pi before, it's now going to be half of that. So that's going to be pi, that's going to be pi on 2, there. Okay, so you've done a vertical dilation this way, and you've done a horizontal in this way. Okay, squished it in. Now the last thing we need to think about is what's going on with this. So we've got a horizontal translation. All right, remember that means you're moving to the right. Okay, negative means moving to the right. So what we've got is that all these points are going to shift pi on 4 to the right. Okay, so if this is pi on 2, this must be pi on 4 up here. So basically what you're looking at is this point is going to move to here, this point is going to move to here, that's going to go there, and so on. So this is going to be pi on 4, then this is going to come up to pi on 2. Yeah. You can do that, or you can keep going. It doesn't actually give you a domain, so we can just keep going. So it'll come back this way. Ooh, it's a bit awkward. So that's pi on 4 there. This is now pi on 2 here, which makes that 3 pi on 4. 3 pi on 4. So you can see this gets a little bit ugly after a while, which makes that pi, and then 5 pi on 4. Okay, so when you are sketching these, make sure you give yourself plenty of room to write in all these all your intercepts and things. And this is at 3, and this is still -3. Okay, so you've got your vertical dilation, your horizontal dilation, and then your phase shift over that way. So that's pretty much all there is to it. What I'm going to do is run through about 4 or 5 examples, I think, of different graphs, so with sine, cos, and tan, and applying different transformations to them, but the same basic principles apply. So start with your base graph and then work through. Okay, the other thing is looking at given domains. Okay, so if they give you a domain to sketch over in the exam question, you must sketch it over that domain. Okay, so starting here again, base graph is cos t. Okay, and we know that that looks like this. Okay, where that's 2 pi. And this is from 1 to -1. Alright. Now we're applying a vertical dilation of 2, so that's going to increase by 2. We've got a horizontal dilation of 1/3. Okay, so that's vertical times 2. That's horizontal times 1/3. And then we're going to be shifting it to the left, that way. Okay, so we can do this pretty much all in one hit from here. Because if you consider, and we know that we're going from -π3 to π3, so to start with, the vertical dilation is pretty straightforward. That just means we're going to go from 2 to -2. Okay, this means that we're now going, the third dilation means that this will now be 2 pi on 3. Okay, so we come down like that and going up, and that's now at 2 pi on 3. Okay, which means this must be pi on 3. Okay, and then the last thing we're doing is moving it this way, pi on 3. So if this distance is pi on 3, if we move it to the left pi on 3, then clearly that point is going to become the new y-intercept, and then it's going to be symmetrical around the y-axis. So that's gone. So we look at this point, this is moving this way, so it comes to here. Okay, that's pi on 3, and then obviously this goes to -pi on 3, and this comes to pi on 3. So it just looks like, whoops, like that. Okay, and to be complete, make sure that you put your little circles at the ends to say that you're including those values, because you've got this greater than or equal to, less than or equal to. Okay, and that's 2, and that's -2. There. Alright, and these would obviously be pi on 6, negative pi on 6, negative pi on 6, and pi on 6 here. Okay, so thinking about your features that you want to include, x-intercepts, y-intercepts, okay, maximum, minimum points, so turning points. When you were doing tan graphs, you also talk about asymptotes, but that's not really relevant for this one just yet. So we'll talk about that in a minute. Okay, let's have a look at another example. So remember, at any point you can pause the video, have a go at sketching this yourself, then run the video again and see if you get the same answer I do. Okay, it's always a good little test of your understanding. Now, this one here is the same as the first example, so 3 sine 2t minus pi on 4, so we go back, first, same as this one. Okay, the only difference is that we've now moved it up 2, so now we have a vertical translation, okay, which is pretty easy to deal with. So we had our original graph that, oops, also paying attention to the domain. So we had our original graph that looked like this when we were just doing just this bit. Okay, now we're shifting it up 2, so move it up 2, and that means it's pretty straightforward. Just consider we've got a line y equals 2 here, and then draw it off that. Oops. Okay, so this is 2, this is obviously going to be up to 5, okay, because your amplitude is 3 plus the 2, this is going to be down to -1 here, okay, and then we've got our points, this is pi on 4, and this is 5 pi on 4. So those were the original x-intercepts, and now we've moved them up, which means we've got new x-intercepts, okay, which in this case we haven't been asked to find. So I might leave that. I know we do that in the next couple of examples, but you could also find your x-intercepts there by solving solving the equation. Okay, I might just pause there and we'll do the next few examples in the next video so these don't get too long.